Nice, but I've talked to so many people that I think we only talked maybe once. You're gonna have to tell me about you again.
Yeah. Uh, Previous talking, you talk about the hydrogen added uh, in the gas turbine, I think.
Yeah.
Added a
Okay.
specific amount of hydrogen and made that oil efficiency up. And
Yeah.
I think after class you sent me a message about you can share some of the slides that about it.
Ah. Yeah.
Remember
Okay.
now?
Okay. While we're talking here, I just got to plug an external hard drive in here that has that stuff on it.
Okay. So this kind of technology they only used in power plants for the generation of tar or power.
Um, well, it can be used. Okay, first of all, I'll have to wait for the hard drive to load, then I'll grab that information.
Hmm.
Um,
Okay.
the first thing to understand is what you're doing is you're cleaning up the incomplete combustion of carbon elements that are in the fuel. Okay, so if you take what's considered to be a fairly clean burning fuel like natural gas, which is CH4, it has one carbon molecule and two hydrogen molecules, and that's kind of the end of the story. So to add a little bit of hydrogen to CH4 really isn't going to do much improvement to it. Now let's
Hmm.
jump up to propane, which has a much longer carbon chain, or even diesel fuel, where you break
It's
into
okay.
the liquid side of energy,
Hmm.
or let's go even farther and talk about low porous fuel oil. This is oil that'll hardly even flow, it's so thick. You usually have to heat it. But the energy
Hmm.
value of those types of fuels is
Very high.
much, much higher than, say,
Then
natural
diesel.
gas, like diesel. So I will use diesel as the fuel example from this point forward because the majority of our testing, at least initially, testing that was done by third party agencies like the Ford Motor Company, worked with our equipment for
Hmm.
6 weeks in their um, engine plant in Southern California. And I'll be using their tests as um, when I talk about numbers of efficiency and stuff, what they told us that we should offer. But the first thing to understand is that because we don't store hydrogen on board, and because we're making the hydrogen with electrolysis, okay, the
Hmm.
amount of
Hmm.
hydrogen we can make is very
Limited.
uniform. Yeah,
Limited.
it doesn't, no, not limited. I can make a lot of hydrogen with
Yeah.
electrolysis if I have a super lot of energy to do it with.
Hmm.
Okay,
Hmm.
but I don't need a lot of energy and I don't need a lot of hydrogen because
Hmm.
what I'm actually going to do is I'm going to put a very, very minute amount of hydrogen into the intake air that's going into the combustion chamber. Whether it's a reciprocating engine or a turbine, the effect of hydrogen will be the same. The same in not necessarily the degree of effect, but the effect in general will be an improvement
Hmm.
over combustion characteristics in the engine. You'll burn more of your fuel, you'll have better fuel efficiency because of that, and you'll have cleaner emissions. How much cleaner? That depends on the fuel, not on the hydrogen. The longer the carbon chain, the bigger the results. So,
Long,
natural
longer
gas, the
longer the
longer the
cylinder.
yeah, the longer
Oh,
the carbon
carbon chain.
chain,
Oh, got it,
yeah,
got it, got it.
longer the carbon chain, the better the results. So diesel fuel, that has a long carbon chain. So Ford Motor Company in 2005, I believe was the year, took our equipment into their labs. This was when Arnold Schwarzenegger was the governor. I remember that much. Okay, governor of California.
Carbon.
Um, yeah. Um, we sent 3 units down to the Ford Motor Company. I accompanied them, and one of my engineers accompanied them, and we spent 3 weeks with Ford. They put these units into their test labs on. They were running two because they changed the units off and on and stuff. They were running two um, diesel Detroit diesel 600 series engines, truck engines.
Mhm.
Okay,
Mhm.
that was the manufacturer. Detroit Diesel's the manufacturer. 600 series was the engine on low sulfur fuel. They ran them under load, injecting into the fuel, injecting hydrogen into the intake air. They played around. We had given them the ratio, how much hydrogen we believed was the prime amount. They played around with different levels. At the end, they agreed that the figure that we had come up with was very similar to the figure they had come up with. And so I'm going to put the actual ratio here in the, actually my that program will probably be loaded by now too. But I'm going to put the ratio here in the chat as soon as I figure out where the chat is. I wish Campbell would stop changing things.
The first one in the chat
There we go.
with bubbles.
Okay.
Mhm.
5/100ths. 5/100ths. Oops. Of 1% of the intake air volume. So that figure right there, 5/100ths of 1% of the intake air volume. That's the amount of hydrogen you want to put into the intake air. So you measure the air. What's the volume? How many cubic feet or cubic meters are going into
It,
that engine per minute?
it's
And
the
you
this
go
is
ahead.
at the atmosphere pressure, right?
Yeah, yeah. This is just for instance, if I was hooking it up on my truck, okay, I have a
Mhm.
diesel truck, my pickup truck. If I was hooking it up on my pickup truck, I would simply take the hose that's running from the electrolysis unit and creating the hydrogen. I would just put it right into the air breather feed hose before it goes into the engine. It's sucking air from outside the vehicle, pumping it into the engine. I would have the hydrogen going in before the engine, of course, and going in with the air. The ratio, 5/100ths of 1% of whatever that volume is.
So this ratio went a little bit up, so it will generate a little bit more water, right? It's not such a big deal when the volume ratio take a little bit higher.
Well, what's important to us is the combustion of the fuel. Okay, we're not really concerned with how much water is created in the process. It's simply, what is the effective combustion? And so when you put this amount of hydrogen in, you will
Mhm.
create what we have been able to measure as the prime or premium level of combustibility, which under the perfect circumstances, we have achieved as much as a 45% improvement in combustion. So that's almost a 50% reduction in fuel consumption. And that's under prime conditions. Ford Motor Company said that in their general testing over a 3-week period, they suggested they showed an average of around 24%, okay,
24.
of
Mhm.
improvement in fuel economy. If we were marketing the equipment into the trucking industry, it doesn't work on a truck engine, but I'll explain that why in a minute. If we were marketing the equipment into the trucking industry, they had suggested that we should guarantee probably 15%. Okay, that we could guarantee that. Whoa, absolutely no, you're going to get 15. We expect you to see about 25%, but you could see as high as 40 under right circumstances. That's what Ford said. Okay. Now, the limitation of the technology is significant. Okay. It will not work on any type of a application where you can vary the fuel and air flow.
Mm-hmm.
Okay. So if I put this on, um, we'll just say any engine, a diesel engine. Okay.
Diesel.
And that diesel engine is running 2300 RPM and it's under a load of whatever amount, however you want to look at the load. Okay, let's say electrical load. It's running a generator. It's running 2300 RPM. I'm producing perhaps 1 megawatt of electricity with a generator on there and it's constant. It will give me, under that circumstance, probably close to a 40% improvement in fuel economy. But if I put it take that the same engine, and put it on a truck, I'll get nothing because every time he steps on that fuel, you change the ratio. Every time you go up a little hill or down a little hill, the flow of air going into the engine changes, but the amount of hydrogen I'm making does not change. Therefore, it doesn't work.
Mm-hmm.
The the
I
ratio,
think I got the idea.
okay, it
There are
has to
two,
be the
two
same.
things. Yeah. Two things I want to clarify. First, if you want to add this kind of hydrogen tank or such kind of equipment into a truck, first, where does the hydrogen comes from? Does it need to go to a hydrogen station to add some hydrogen, or you have to add some extra electrifying systems like can turn water into oxygen and hydrogen? It's the first question.
Um, well, the first thing we do is we divert a percentage of the exhaust into our system. So your exhaust pipe, we're going to take 10% of your exhaust to our use.
Mhm.
90% is still going to come out your exhaust pipe. That 10% that we take, we're going to exit it out of the system as well, but we're going to cool it before we do. And as we cool it, the water will precipitate out of the exhaust. There's a high level of water vapor in the exhaust.
Mhm.
So we're going to take the water out of the exhaust by cooling the exhaust, condense the water. We then put the water through a series of filters right on the engine. And when it comes through out of the third filter, we now have deionized purified water. That
Who?
deionized water.
Yeah. That's coming to the tricky part. How do you deioninize the water? Where does the power come from? In a car, not in a power station.
Um, we don't use power to deionize water. We use filters. Uh, the
Filters.
filters, yes, yeah. So you have anion and cation ions in the water, and you have what are typically called ion exchange resins. So you can
Mm-hmm.
take a cation resin and extract all of the anions from water, and you can take an anion-based resin to extract all the cations from the water. So if you put it through each of these, so what we do is the first filter we take out is basically activated carbon block. The first filter it goes through takes out organics and a bunch of other stuff. Second filter it goes through is 3 stages of sediment down to zero point zero 0.05 microns. So when it comes out of the second filter, you're you're down to 0.05 microns, but you still have all of your ions, which will produce conductivity. The third filter stage it goes through is first through a cation resin, then through an anion resin. When you come out the other end of that one, you have deionized water. The deionized water now goes into the electrolysis unit where it makes a set amount of HHO gas from H2O water. Inside of the electrolysis unit, because the water is deionized, it will not conduct electricity. So we use a 30% KOH, potassium hydroxide solution. Okay, so we use a 30% KOH solution inside the electrolysis unit, and we pull just a small amount of electricity off of the alternator of the engine and produce in the vicinity of usually somewhere between 200 and 300 milliliters of hydrogen a minute. depending on the size of the engines that we're running. If we're running turbines, then it's quite a bit more that we're making because the air ratio of a turbine is much higher air volume than in a reciprocating engine. 14.7 to 1 typically in a gas engine. A turbine could be 100 to 1 air to fuel ratio. So that changes it.
Do you have to change the filters very often?
I'm trying to think back on that one. I'm not sure. I don't know. I don't know what the filter change requirement was. That was done by engineers on site, and the filters that they replaced were supplied by us. But see, every engine's different size and a different flow, so you'd have different filters on. But yeah, you would have to change them for sure. How often would depend. Yeah.
Yeah, the maintenance is often very very important for the on-site management. Yeah.
Everything, because we were running a lot of remote equipment, everything that needed regular maintenance was automated. So for instance, on your filter lines, we had 3 lines of filters, and then there were both testing meters after the filters to make sure they were maintaining the quality of water, the deionized water. So we had conductivity meters after the filters. And then ahead of the filters, we had diverters. So as soon as we started getting a reading on our conductivity meters telling us that this filter line was starting to break down, it needed to be changed, it would just automatically divert it over to line number 2. Line number 2 would automatically pick up now. Line number 1 would become dormant. When line number 2 started to deteriorate, it would kick over to line number 3. When it went into line number 3, that's when the engineers on the oil sites where we were operating these units would then come in and change the filter packs for line number 1, line number 2. And it would just keep rotating like that. How often they had to change that 3 filter pack, I'm not sure.
Okay. I think I'm not that very clear for how the filter is working, but I sort of know how the process itself. So are the slides ready now?
Oh, yeah, okay, just give me a sec here. I'll grab that, open up that hard drive, and we'll jump down here to Green Electric Power. Where are you?
These kind of equipment.
The name of my company was Green Electric Power Corporation.
Oh, so you just retired? You does not sell the company?
No, the company is still operating, but we don't do any marketing now. So we still have a website up at greenelectricpower.com, but we took the original website down and I just put up a couple landing pages that are just very, very brief because we don't market anymore. So I want to.
Could you send me a link or something?
If I write a link in the chat, Cambly will get mad at me. They have they do. They have an algorithm that they'll degrade my rating if I send you an outside link. Like if I even want to give you my LinkedIn, okay, my LinkedIn address. If I type it in here, I'll get a letter from them. I can tell you, okay, if you go to, I can even write my name here, but I can't put a URL in. If you go to W. So here's my LinkedIn friends. This is W. David, which is simply my name. Okay, that's my name on LinkedIn, and you'll know you got the right me because you'll see Green Electric Power Canada Limited is the company.
Yeah. I think I will find that company. Yeah, LinkedIn got lots of information.
Now let me get back to this this presentation. I'm going to give you a complete presentation. GEPC technical presentation. That might be it right there. Let me have a look here. I also got to look at this is in Keynote, which is an Apple program. You're not on an Apple, are you?
Okay, I'm using a Mac 2 Pro,
Oh,
Mac 2 Air.
okay. Oh, good. Well, then I can just send it to you. I've got it here. It's a Keynote, which is an Apple program. I stopped using PCs 25 years ago when Apple came out with their very first laptop, the old white MacBook. That was the end of it for me. Now, yeah, this is the right one. Okay, good. Now, I need to attach that here in the chat. That means I gotta find the chat program again.
The fourth one with bubble. So this kind of equipment are only used in gas stations right now.
Gas stations.
No. Power stations.
Yes. Yeah, only in power stations and compressor stations for compressing gas into pipelines.
Oh,
Just give me 1 second here. I've lost myself again now. That's what happens when you start getting older. You can only think of one thing at a time.
which means you are focusing on one thing.
Now, so I want to pull that across and put it in here. I got to find this profile again.
You could drag and put there.
Yeah, I got to get it all. I got to find the place where it goes. Here we are. Okay, I got it. They got a whole bunch of buttons that all look the same that you never use, and the chat is mixed into the middle of it. Okay. Now, I don't think I can drop it in, but I'll try it. See if I can drop it. I think I have to attach it, but we'll find out right here.
Oh, that's okay. You leave the message itself is also okay. The message. So
that didn't work.
That's okay. You can.
So I'm going to have to go up here to the chat.
Don't bother. Could I share an email address?
Yeah, I can send it to you that way.
Just double check. Changjian Fang at Siemens Energy, SIEMEN, Siemens Energy. I think this one. Changjian.fang at siemensenergy.com.
You work at Siemens?
Yeah, I'm at Siemens Energy. Yeah.
Oh,
no. Siemens Energy.
You didn't tell me that before I told you all my secrets.
It's totally different. We are manufacturing about the switchgears, not the gas turbines. Switchgears.
Okay, let me. See, they make it so difficult to pass something to you here. I can't even find a way that I can attach it. There's no attachment in the regular. Oh, okay, here, yeah, there's your email address. So I'll take that.
So I think that very promising when if it's applicable to the diesel engines and the trucks, big rigs. Yeah.
Okay, I got it here. Good. Well, there it will go.
So I booked another.
Okay.
I booked another half an hour tomorrow, an hour earlier.
Okay.
And
Oh, come on.
Okay.
That didn't work. What the hell? What's going on? Compose. But, oh, it won't even let me copy it? You gotta be kidding me. You mean I can't
You
even copy your address here? Now let me
you
try this again.
right
Control
click,
C.
right click. There should be a copy shortcuts.
Yeah. Try that again. Okay, there I got it. And then I'm just going to write GEPC. And now I can grab this file and I can drop it in there. Bingo. I'll let that load.
Yeah.
It's loaded. Okay, here it comes. Send. Now this presentation was done back around, I think around probably about 2005. So it's
2005. Oh.
yeah,
17
quite a
years
while
ago.
ago.
So the kind of limitations make the technology less promising, I think. If it can apply to the car industry, it can make a quite fortune.
So you're in the refrigeration department of Siemens.
Refrigeration? No. Siemens Energy. Totally different from the Siemens. It's energy section. We are at
Yeah.
the grid technology, the power grid. We are producing the equipment used in the power grid.
Okay.
I think I got the email. Yeah, thanks for sharing. I think I will read it. We can talk more details about it tomorrow, about this topic.
Yeah. Yeah, that presentation gives you the actual combustion process, what is happening in the combustion chamber. It gives you the chemical equations. Believe me, I don't even understand them. Okay. Those parts were written by the engineers. This is all part of the stuff that was submitted to the Canadian government. When I opened my company, now we're not going to have time, but I'll give you a little bit of it. When I opened my company originally in 2002, I didn't have the kind of money that I needed to hire 7 engineers. Come on. Any one of them makes more money than I make in a year. How the heck could I pay 7 of them? So what I did is I went and found the engineers first. I went and talked to engineers at many universities. And basically, I did the same thing every time. Here's my business plan. Have a look at it. Okay. Now, once you've looked at it, would you be interested in working with us on a research program if I could afford to pay you?
You convince them without any actual payment to them, and they're leading them to start the company.
I convinced them to come. Depending, the condition was, again, I'll say it again. Okay, will you come and work on this project with my company if I can pay you? Okay. Right now, I cannot pay you, but would you come and do it if I could pay you? You would. Good. Okay. So what I did is I found 7 engineers who said, yes, if you could pay me, I would be interested. I'll have to tell you the rest next time.
Thanks. See.